The quotient rule, good news, it's only 4 slides. It is a rule. Okay, so like I said, the product rule, you're going to say this over and over. You're going to get tired of it. The quotient rule is the same thing. It's really hard to do this. You can't just do derivative of this over derivative of this. You can't do them separately, just like you can't do with multiplication. Okay, this, like with multiplication, I said you could FOIL it way out if you wanted. You could have done that in your quiz. So if you didn't know when to use product rule or not, it still worked for a few of them if you multiplied things in and then did it normally. But here, I can't cancel stuff unless it factors. So quotient rule, we kind of get stuck where we really have to use quotient rule. We really can't use any other properties. So the saying that you're going to say over and over, kind of like quadratic formula style, it goes low d high. So d means derivative, minus high d low, all over low squared. That is the saying for the quotient rule. So low d high, high d low, all over low squared. That's the shorthand notation of saying it. So obviously low and high refer to the numerator denominator. Okay, so high is the numerator, low is the denominator. Okay, again, I'll save you the pain of proving it. If you want to look through the proof, if it's interesting, you can look through it in the book. Any questions on that? I mean, it's a formula, so is there any questions about the formula? You can see how things are going to start getting longer. Okay, so we start getting into those parts where you got to be very organized. Well, I'll pause it here. I'll let you guys get those notes down if you need to. So again, I'll restate it. Restate it. We do need the order does matter. Okay, order doesn't matter with division. Just like 1/3 is different from 3/1, you have to do them in the correct order. Okay, this is the Lebanese way of writing it. That just has the d over dx. D over dx. Don't ignore this. I know it means the same thing, but when we get to harder differentiation, we're going to be using those quite a bit because it helps us actually organize more effectively. Okay, so just know that when we put this up here, don't completely ignore it. Understand that just means g derivative of f minus f derivative of g. That's all it means. Okay, d over dx means derivative with respect to x. Okay, keep that in mind. All right, let's do the first example here of 2. So here we go. Low d high minus high d low all over low squared. That's your setup. Now we go to work. So again, I'll label. This is low, d high, high, d low, low squared. If you're wondering, we have to FOIL that out. Yep, we do. Okay, combine your like terms. 2x to the 4th plus 2x cubed plus 2x plus 2 minus
Junior class change.
3x to the 4th 6x cubed and minus 9x squared. You don't have to keep writing the bottom. We know what's down there. Okay, and we don't need to FOIL the bottom out yet. We may sometimes, but we want to kind of leave it and see what happens on top first, like we did earlier for limits, where I said don't multiply that stuff in, see if stuff's going to cancel. So leave that be for a little bit until we get the top fully done. Okay, any questions? Okay, so we just got to combine like terms here. 2x 4th minus 3x 4th, that's a negative x to the 4th. 2x cubed minus 6x cubed is a negative 4x cubed. 2x minus, there is no other ones, so we'll keep that 2x, and there is no constants. And we're minusing a negative 9x squared, so that's plus 9x squared. So clearly you can see I have a constant. There's nothing I can pull out. I'm done. I can't do anything from here. This is the derivative with this on the bottom. This is f prime of x. That's it. So again, this still represents the function for what? Back to the basics. What does this represent? The tangent slopes function, right? This represents a tangent slopes function of this equation. So if I want to find the tangent slope at 2, I plug 2 into here, just like you do on your quiz. Okay, yeah, get some work to do. You got to figure out what that is, but it's still going to give you a value because the x's are all good. Okay. Is there anything you can't get a value for? Think about your non-permissibles. -1. -1 cubed is -1. -1 plus 1 is 0. I can't divide by 0, so therefore I can't get a tangent slope at -1. That means there's an asymptote there. That's interesting. Why? Well, look at the top. The original also has an asymptote there. So if there's an asymptote in the original, you can't have a tangent slope through an asymptote. So that makes sense. Okay? Does that click? Okay, let's do the second one here. And that's it. Okay, so they're just saying this dy dx, they're writing in Lebanese. It's fine, not a big deal. So here we go. All right, low d high. We've done this one a bunch, so we kind of know what that is. That's 1 over 2 root x minus high d low. You can change that to 1/2 if you want. Maybe I will in a second. And that's a 2 all over low squared. Okay, I'll let you get that down for a second. Okay, so what I'm going to do here is I'm going to put this on top here, and I'm going to try to get these to have a common denominator so I can put them together as 1. Okay, so I'm going to write this as 1.2x. I'm going to leave the bottom the same, so I'm not going to keep writing it. It's going to be on top of 2 root x minus, this is 2 root x. So how do I get that to be over 2 root x? I times it by 2 root x. That's just common denominator work. So my top now is this. That. So that's going to give me -2x plus 1 over 2 root x over 1 plus 2x squared. The reason this is helpful sometimes these will cancel. This one was just barely not it. If you're saying, well, pull a negative out. Well, they're not completely opposite. They both have a positive 1, so I can't do anything to make these the same. But where does this go? If we want to write this fully simplified, where does it go? What's that? Down. It goes right there. So your final answer for the derivative of y, so y prime, is -2x plus 1. 2 root x, 2x, I wrote it, sorry, I just wrote it the other way on the accent, 2x plus 1 squared. And that's it, that's the derivative. Okay. So, I mean, the lesson's not long because it's the same thing over and over. It's just about, again, the hard part is you staying organized, you not getting lost in your work, because you can see it just kind of gets a little bit overwhelming at times. Okay, so that's going to be the difficulty here. Okay. So some of you pen users there, Logan, you got to be careful. Oh, got a pencil today? Or pen? Oh. Okay. Okay, so that's it.